Yeah, wait for 2 minutes. Voice out. Last bench. Can you hear me? Last bench. ఇప్పుడు వస్తుంది కదా. Okay, guys. So in today's class, we are going to discuss about the decision trees. Okay, the HTML algorithm. Before starting, online students, can you please confirm? Is my voice is loud and clear? Till now, there is a problem in offline. Online students, can you please confirm? Yeah, it is clear, right? For you, it is clear, right? Done. So the topic is decision trees. Now, it is also one of the type of a classifier, and where it is also going to work and where it is going to classify the output variable. So in today's class, we are going to see what is decision tree, what are the various terminologies used in the decision tree, and what are the different splitting criteria used in the decision trees, and what are the advantages and disadvantages of decision trees. So these are the things which we are going to cover in the today's class. Now, decision tree is a supervised machine learning technique. Decision tree is a supervised machine learning technique where the data is split according to the certain condition by parameter. Okay, it is split according to a condition or a parameter. Now, here let us assume to classify whether a customer should retire or not to retire based on his savings and age. So I'm having two columns. One is called as savings and second column is called as age column. And I'm going to make a scatter plot between them. And this is the scatter plot. Okay. Now in this scatter plot, I'm having certain red data points and certain blue data points. Each data point, in order to make a scatter plot 1 point, we require one X variable and one variable. So if you remember, in the logistic regression also, I have explained you X1 and X2 with Y. In KNN also, I have taken with X1 and one X2 and Y. In the STS class, whatever the SVM we have discussed, in that also I have taken one X1 variable and one X2 variable and Y. So in the all of them, I have shown you the scatter plot. If you remember, in the KNN also, we have discussed the scatter plot. Within the scatter plot, I'm having two different categories. One is red category, one is with respect to some blue category, some data points like this. And we have classified. In the yesterday's SVM also, if you remember in the yesterday's SVM also, we have taken some of the different color and some categories of different color, and we have applied a SVM over that while explaining. And why I'm selecting with respect to these scatter plots, why I'm selecting the scatter plots of x1 and x2 and y variable, why I'm selecting only two input variables means in order to show you the scatter plot. Okay, based on the scatter plot and by showing the diagram, how it is going to work, I can show you. For example, if I take a 3 columns or 4 columns, for example, x1, x2, x3, x4 and y, if I take like this 4 variables at a time, now if I want to show you the KNN, nearest neighbor it has to identify means, for how I can show you, how I can draw a plot for with 4 variables, 4 input variables and 1 output variable. It is not possible, right? So that is the reason I'm selecting a simple data set of 2 input variables and along with that 1 output variable. Okay, where I can have the scatter plot, and using the scatter plot I can explain with by showing you the diagram. For whether it is a KNN means, I'm going to show you it is going to identify the nearest neighbors. For each and every data point, it will identify the distance. Whereas in SVM, it is going to draw a hyperplane, which is a linear line. So like this, I can explain, right? So now here in this example also, I'm going to take the same way, where I'm having 2 input columns and 1 output column, x1, x2, and y variable, where x1 is the savings and x2 is the age. And the third one, output variable, is whether the person has to retire or not, yes or no. In the output variable, I'm having either yes or no. Input variable will consist of certain savings values. Age column consists of certain age values, right? These both of them are continuous variable, and this is the output is the discrete variable. I'm having a data set in this way. Now here, these red data points indicates, the red color data points indicates not to retire. Blue color data points indicates retire, to retire, right? Now I'm making a scatter plot between the input variable, that is age versus savings versus, and whether the person has to retire or not to retire. Okay, I'm taking a data, I'm taking a scatter plot between this, where between the x1 and x2 variable, I'm making a scatter plot between x2 and x1 and x2 variable, along with the, by considering the discrete variable y. That is by writing the hue is equal to output variable. In the scatter plot, I'm going to write hue is equal to output variable. And I'm going to get a scatter plot in this way. Now, the basic intuition behind the decision tree is to map all the possible decision parts in the form of tree. It is going to create a tree. Means, for example, this is the data set given. And in this data set, you want to separate the data points of each category. And you want to identify if a new person, completely a new person, this is the age of that savings of that person, and this is the age of the person, whether this person has to retire or not. Based on this data set, okay, you have to predict whether this person has to retire or not. So how we are going to do that one? In the KNN, we are going to identify the nearest neighbors. In the SVM, we are going to draw a line and we are going to separate the data points. And from that, we are going to identify whether this point belongs to either red category or blue category. Now in decision tree, how we are going to make this one? Here also it is completely the decision tree is to map all the possible decision paths. All the possible decision paths. Decision paths are nothing but conditions. So here I'm going to write condition number 1. Okay, first I'm going to write a one condition like this. So first I'm going to identify this, what is this value? For this value, I'm going to create a line. So savings greater than 1 million. I will write one condition like this. This is called as condition. First, I'll take the first condition. Okay. And based on the condition, voice is not audible. Guys, others, can you please confirm? Voice is clear? Okay. Done. Just a minute. Okay. So here we are going to take a condition, and based on the condition, you are going to write one condition. And based on the condition, if the condition is true, if the condition is false, every time you will have only two, because in the if the condition is true means the if block will work. If the condition is false means if block will be ignored. Similarly, in the same way here also same. You are going to take a condition, and for this condition, the condition is true and the condition is false. For example, this is the condition, savings. So this particular column, whatever the column I'm going to take on the x-axis is nothing but savings. Now savings are greater than 1 million. Savings are greater than 1 million means this side. This is the part. Answer is true. Answer is true means if the condition is true, that is savings greater than 1 million means you are having two categories with you. You can't classify. But whereas if the savings are less than 1 million means you are having only one and only answer directly, which is class red. Okay. So the savings are less than 1 million means directly you are having the answer as red category. If the savings are greater than 1 million means you are having the both red and green categories. Now again, within that, now you are going to take one more condition. Now one more condition is I'm going to draw like this. This is one more condition. This line, whatever the line is there, this is one more condition. One more, what is this condition is age at 45. Now age is greater than 45. Age greater than 45 means which category? Age less than 45 means which category? Age greater than 45. If it is answer is yes, what is the answer? If the age is greater than 45, what is the answer? Blue color is the answer. That is with respect to blue. And if the age is not less than, if the age is less than 45, what is the answer? Red. No miss red. Simple. So the same thing will be taken. Right? One more with respect to, and we are going to separate the data points. Now, if any particular person like this, a new person is there, you want to predict on a new person. For this new person, we are having with respect to the savings and the age, two values will be there. Now, first, what we are going to do for this new person, for whatever the unknown data, we want to predict whether the person has to retire or not to retire. First, we are going to check what is the savings amount. First, we are going to check the savings amount. If the savings amount is greater than 1 million or less than 1 million, here in this case, it is greater than 1 million or less than 1 million. It is less than 1 million. Less than 1 million means directly it belongs to class 0. That is red color. Is that clear, guys? Now, if the savings are greater than 1 million, if the savings are greater than 1 million, let us assume I'm having one more point like this. If the savings are greater than 1 million, at the same time, age is also greater than 45. Now, this person has to retire or not to retire? Means he can retire. Okay. So based on the data set, I'm having a data set with me, where in the data set I'm having with respect to age, savings, whether the person has to retire or not to retire. I'm having a certain data set. Now, whatever the data set I have taken, for this data set, I have created a decision tree. This is called as a tree. Decision tree. Now, since it is looking as a tree type structure, so it is called as a tree. And where decision means based on the condition, you are going to take the decision. Whether either that category or this category, you are taking based on the condition. Now, first here what happens means completely whatever the given data is there, based on the given data, we are going to make a decision tree. So in the given case, I'm taking the savings are greater than 1 million. That is yes, no. Again, I'm going to take with respect to age greater than 45. This is pure red class. That is not to retire. Red class means not retire. And the age is greater than 45 means retire. And this one is not retire. Don't retire. Not retire means don't retire. Whether the person has to retire or not to retire means you have to say as don't retire. Right? Now, here, this is always with respect to left side yes and right side no. Every time it is fixed. Every time it is fixed. And so here a person of new person, age is of 70 and savings of 2 million, and whether this person has to retire or not to retire. Or sir, 70 age means everyone will say that in India as per see more than 60 retirement age, no sir. Okay, let us take 45 age or 44 age, something like this. Okay, now first what you are going to do? First you are going to check what is the amount he is having. 2 million. 2 million is greater than 1 million. Since the answer is yes, now you have to check the condition. Now what is the answer? Age is greater than 45. Age is greater than 45? No. The answer is no, miss. What is the finally answer is? Don't retire. So that is the prediction. In that way, the machine will predict. First, it will create the decision tree for the given data, and the unknown data will be passed into the decision tree, and finally, in which one it is going to show the answer, it will be the answer. Okay. For the given data set, first it will create the decision tree. It will be created the decision tree for the given data set. Given data. For the given data, it is going to apply the decision tree. Okay. For the given data, it is going to apply the decision tree. And once the decision tree is applied, right? Now, once the decision tree is applied on the given data set, now for a unknown data, a new data, what it is going to do means it is just passing that information in this decision tree, and finally, whatever the answer you will get, that it is going to predict the answer. For unknown data, it is going to work in that way. For the known data, it is going to create. Sir, in this question, for example, let us take like this. Okay, in the same question, let us take like this, where I'm having the blue data point, one more data point also here. Now I'm having a blue data point here. In this case, how it is going to work? Now, it is going to take a line in this way. Any value less than to this is a red data point. Any value greater than to this also a red data point. And it will create one more row like this and one more like this till you get a pure answer. Till you get the correct answer, it will make the number of conditions. Okay. Till you get the pure answer, it will take the number of conditions. Right? Is that clear, guys? So, for example, if you are having like this in terms of till you get this one also classified as a single answer. For example, if you don't do this one, in this category, you may have both the red color and blue color also. Here you may have both red and blue. So you should not get the both red and blue. Till you get the blue as the separate answer, it will do the classify. For example, here also blue is there. Again, it will separate the data like this also. Here also it will separate the data by writing the multiple conditions. Okay. So the more still you get the 100% as the pure answer, it is going to subdivide the data. Is that clear, guys? Now, if you take one more example like this, where I'm having the income and the credit score. One side I'm having the income and second side I'm having the credit score. These are the two input variables, and the output variables is red and blue. Once again, the output variable will consist of red category and blue category. Right? Now, what I'm going to do is, once again, I'm going to take a first line, that is credit score less than 750. So credit score less than 750, less means which category? Less than 750 means credit score 750 means this is the line. Less than 750 means this is the part, below part. This everything comes under this one. Above 750 means this everything comes under here. Now, the below part is not having a pure red class. Above part is also not having the pure red class. Means you have to write one more condition. If it is having the pure class means directly write the answer, red or blue or whatever it is. If you're not able to have that one, again you have to take one more condition. Now here I'm taking one more condition, that is income less than 200K. Where is income less than 200K? This is, so it is going to draw a line like this. Now within this, answer is true, less than 200. What is the answer? What is the output? It is a red category. For no means income greater than 200. This side, what is the output? You are having the both red and blue. So whenever you are having both red and blue as the output, again you have to write one more condition. If two classes are there in the output variable, means Then you have to write one more condition. And this time you are going to write one more condition again based on the credit score. Using the credit score, again, you are going to draw one more line like this. And again, you are going to separate the data points. Now you'll get with respect to one side red and one side blue. Now coming to the above part, you are going to take a line like this and you are going to separate the data. So this line, whatever the above is there, that line, see here, I'm taking with respect to income less than 100K. Exactly at 100K, I'm going to draw one line. Income less than 100K means, if it is true means, it is called as blue category. If it is false means, it is called as red category directly. But whereas this one, income less than 200K, less than 200K is called as a red category, but more than that is not called as red category or blue category. Again, I have to take one more condition here. I have to write one more condition. And based on the condition, again, I'm going to separate the data. Right? Like this, we are going to separate the data and it is going to be continued till you get the pure class as the answer. Okay? Till you get the directly one as the output. You should not get the output in the output. Sir, in this, both blue and red will be available. You can't say like that. Till you get the class one, anything. Till that, you have to continue. Right? Now, so let us take with respect to, now what is the objective of the decision tree? Means the objective of the decision tree is to get the pure nodes. Okay, after applying the multiple conditions, you have to get the pure nodes. Till you get the pure nodes, you have to apply the decision tree, right? And what are the different terminologies are there in the decision trees? Means the first one is called as a root node. The starting opening, first you are going to take one condition and based on that splitting will start, right? That is called as a root node. And from the root node, it is going to split into the right side branch and left side branch. Okay, two sides. It is going to take left side and right side. One is yes and one is no. Always this side is yes, always this side is no. Every time. And that too, you are having either yes or no only. You can't get from a single node the third one, fourth one, like this you can't get. From once based on the condition, it is going to divide into only two parts. Okay, based on the condition, it can be divided only into two parts, either S category or no category. And this one, if you write one more condition, if you are writing one more condition, it is called as decision node. It is called as decision node. Wherever you are going to write the conditions, it is called as decision node. And the last one, finally, where you are going to end, the node will be ended. The node will not be furtherly splitted. The node which will not be furtherly splitted is called as leaf node. The node which will not be furtherly splitted is called as leaf node. And this is called as subtree, left side branch and right side branch. These are called as branches. This is called as left side branch and this is called as right side branch. Next one is depth of the tree. Depth of the tree means how many times the tree has been furtherly splitted. If one of the node is furtherly splitted also, it is considered as one of the depth. If at least one node is splitted also, still you have to consider the depth. Is that clear, guys? So let's see with an example, whatever we have done, terminologies. So in this, if you observe here, I have taken the first opening. Here itself, I have written the condition. Sir, you told that wherever you write the condition is called as decision node. Yes, all the condition nodes are called as decision node. Wherever you have written the condition, every node is called as decision node. The first one is called as a root node. The first one is called as root node. Basically, it is also a decision node only. But since it is the first one, it is the root node. And based on the root node, you are going to split into two parts. This is called as splitting the data into two parts. Based on your condition, you are entirely splitting the data into two parts. Okay. And once you have splitted the data into two parts, now this is the first part of the data. This is the second part of the data. This entire thing is the first part of the data. This is entirely second part of the data. Okay. Now here, this is called as a root node. This is called as decision node. This is called as decision node. Okay, this is called as decision node. This is called as decision node. Wherever you are going to write the condition, everything are called as decision nodes. These three of them are called as decision nodes. And this one is called as leaf node. Leaf node, because after this it is not getting splitted. It stopped. Finally, whatever you are getting is called as leaf node, or which is also called as terminal node. Terminal node. Terminal means it has terminated, the last stop. Okay, so terminal node, leaf node or terminal node. This one is the leaf node or terminal node. This one, leaf node or terminal node. This one, leaf node or terminal node. This one, leaf node or terminal node. Right? So everything are leaf nodes or terminal nodes. These are all of them, because it is not furtherly splitted. But these one are furtherly splitted. So this, whichever the node was furtherly splitted, by writing the condition. Without writing the condition, you can't split. 100% you have to write the condition. Okay. And if you write the condition and based on that you are splitting means, then it is called as decision nodes. Is that clear, guys? Now, so terminologies are clear. Root node, splitting, decision node, leaf node, and subtree, and finally the depth of the tree. Now for this example, what is the depth of the tree? 3 is the depth of 1, 2, 3. This is the depth of the tree. 3 times it has been furtherly splitted. Right? At least, sir, in this, this one not splitted, this one not splitted, this one not splitted. Only one node only splitted, right? If at least one node gets split also, it is considered as the depth. Okay? If one node gets split also, it is considered as the depth. Right? Next. How to select the split point in the decision trees? How to select this one? The question is, if you see this, there is a most important interview question in the decision trees. What is that first important interview question, miss? Sir, for example, this is the date. This is the data you are having. Now you can create a data like this. First, you can write a line like this, followed a line like this. First line, what you are going to draw? This is the first line. In order to draw this line, which variable you have to consider? This is the variable which you have to consider, because saving some value, this is some value, and based on this value, you are going to split into 2 parts. So you have to take the savings as your starting value, and you have to split the data. And after that, you are going to draw one more line like this. And this time you are going to consider the age parameter, and based on the age value, you are going to split. Now, this is option number 1. Option number 2. Directly, I'm going to take my first line here itself. The first line here itself, and that is age. I'm going to start with the age. Age is less than 45. I'm going to start directly with the age. Now, age is less than 45 means below part. So below part directly it is red. And above part, again, I'm going to split the line like this. So first I'm going to draw a horizontal line followed by vertical line. This is option 1. And I can draw a vertical line, one vertical line followed by a horizontal line. This is option number 2. Which one has to be selected? Either this or this. And coming to the next, in this example, if you go with this example, you have started with your first line by considering this one, a horizontal line. You have taken a first opening, a horizontal line like this. Instead of considering a horizontal line, why you can't consider a vertical line like this? You can take a vertical line like this, a vertical line like this. After that, you can take a vertical line like this, a vertical line, a vertical line. This is also decision tree where you have split it. That is also one option. This is also one option. Now, which one is the best option? Which one is the best option? That is the question. Which option is the best option means which gives the less depth of the tree. Okay, depth of the tree should be low. A decision tree which gives the least depth and with maximum accuracy, that is the best one. Okay, which will have with respect to less number of decision nodes, which will have with respect to a decision tree which has less number of decision nodes, and the perfect split will be completed. That is the best one, which has the less number of decision nodes. So here I'm going to take condition number 1, condition number 2, condition number 3, condition number 4. 4 conditions I'm taking. For these 4 conditions, by writing these 4 conditions, I'm going to have like this. The depth of the tree I'm going to get as a 3. In this depth of the tree, I'm having condition 1. This is the condition number 1, condition number 2, condition number 3, condition number 4. Total 4 conditions are there, and the total depth of the tree is 3. Now, if I try in a different way, okay, that is first I'm going to try with this. Starting, I'm trying with this. So I'm writing one condition. This is the condition number 1. And in the condition number 1, I'm going to get with respect to left side area and right side area. Okay, let us assume this is the left side one. Okay, in the left side one, again, I'm going to write one more condition. This is condition number 2. And by writing the condition, I have got directly red and blue completed. This part is completed. Now coming to the right side area, this one, I'm going to write one more condition here. And I'm going to split the data into 2 parts. 2 parts by writing this condition above this one and below to this one. Above to that one is pure red color, and below to that one is red and blue, both are there. Now again, I'm going to write one more condition. I'm going to write one more condition. The one more condition is this one. Okay, this is one more condition. Okay, using this condition, below one more side is red color and right side is again red and blue. I am writing one more condition. Now finally, by using this one, I have got red and blue. Now what is the depth? 1, 2, 3 and 4. How many conditions you have written? 1, 2, 3, 4, 5. 5 conditions you have taken. So total 5 lines will be there. Each condition, each line. Just observe here, total 5 lines will be there. Either vertical line or horizontal line, total 5 lines will be there. Right? So each condition is with respect to one line. Now here, with respect to I'm having the depth of the tree is equal to 4. When compared to this one, it takes certain time. It will take certain time. Now, this will also will take the certain time. In this case, this one also will take certain time. This will also take time. That will also will take time. Out of these two, both of them are giving 100% pure answers. But out of which will give in the less time? This one or that one? The previous one. This one will give in a less time because the depth of the tree is less. With less number of conditions, you can split the data in a quicker way. In a quick way, you can complete. So for doing this one, what we are going to use means the root node. How we are going to select the root node? Whether the root node will be selected on the variable x1 or using the variable x2. Which variable you are going to select? In the given data set, multiple variables will be there. In that variable, which variable you are going to select? Either savings variable or age variable, or which variable? Which variable you are going to select as your initial node? That is the most important. That node will be selected based on the Jenny impurity. The root node will be selected based on the Jenny impurity. Now, what is meant by Jenny impurity means 1 minus Jenny index. Okay. So for example, I'm having the multiple columns. I'm having the multiple columns, or instead of multiple columns, let us take the same example. I'm having x1, x2 and y. I'm having with respect to x1, x2 and y. Now, if I'm having x1 and x2 and y, now I have to take a root node by writing one condition, that is either x1 less than or x1 greater than, using x1, or with respect to by writing the x2. Which variable I have to select? For example, let us take the first example only. This is age. and this is the savings, and this is the whether the person to retire or not to retire only is there. Now in the numerator in this, should I select the age? Should I select the savings? What should I select in the root node? What variable I have to select in the root node? That is the interview question. Which variable you are going to use for your splitting? Means I'm going to calculate the Gini impurity of the first variable, Gini impurity of the second variable. I'm going to calculate Gini impurity of all the variables. I'm going to calculate the Gini impurity of all the variables. After calculating which variable has low Gini impurity, that particular variable I'm going to use. The variable which has the low Gini impurity, that one I'm going to select as a decision node. Every time I'm going to calculate for the data the Gini impurity values. Okay. So Gini impurity will be calculated, and based on the Gini impurity, I'm going to once I calculated the Gini impurity which is having the low Gini impurity, that particular variable will be selected. Now, how to calculate the Gini impurity? Gini impurity is equal to 1 minus Gini. 1 minus Gini index. Now, what is meant by 1 Gini index? Sigma p square is called as Gini index. 1 minus sigma p square. Now, what is meant by sigma p square? 1 minus sigma p square means first p1 square plus p2 square plus p3 square plus so on up to pn square. Okay, multiple probabilities you are going to square and you are going to add. Now for first class, you are going to calculate the probability and square it. Second class, probability and square it. Sir, how to calculate all these things means, let us see one data set and let us do the calculation one by one. So in order to calculate the Gini impurity of the nodes, we have to calculate 1 minus Gini, where the Gini is the sum of the squares of the probability of each class or category. If it is a binary class classification problem, you will have only 2 classes. If it is a multi-class classification problem, you will have the 3 classes. Okay, in the output variable, if you are having more than 2 classes, P1 square, P2 square, P3 square, like this you have. If you are having only 2 classes, P1 square and P2 square. Okay, in the output variable based on the number of classes. So now the decision tree is applicable for both binary classes and also for the multiple classes. This is one of the advanced algorithm. Whereas logistic regression or KNN or SVM, these 3 of them are applicable for the binary classes. It will give a very good result for binary classes and for the small data sets. Now if you move on to the decision tree, one, it is applicable for the large data set, and at the same time, it is applicable for the multi-class also. Not only applicable, it will give the very good result also for multi-class. Okay. But whereas in the logistic regression, if you try for the multi-class, you will get a worst results. It is applicable. There is a technique called as OVR, one versus rest, in the logistic regression that we'll see in the artificial intelligence. At the time, I'll explain that one, right? So there is a OVR technique. OVR technique means one versus rest. Means, for example, if you are having 3 classes, class 1, class 2, class 3, 3 classes are there in the output variable. In the output variable, you are having 3 categories. I mean, drug X, drug Y, drug Z. Output variable consists of 3 categories. Now for this, if you apply the logistic regression, basically logistic regression, it is going to work on the concept called as sigmoid. In the sigmoid, it is going to calculate the probability, and based on the probability and threshold value, you are going to classify into the classes. Now what happens means, if you are having 3 classes and if you give the logistic regression, it will consider this one as the class 1 and it will consider this one as the class 2. These 2 variables, it will be considered as class 2. And within the class 2, again, it will identify which is having the higher probability. Like this, it is going to apply. That is called as OVR technique. One versus rest. OVR means one versus list. So this will be considered as one category. Rest of them will be considered as one category. Again, in the rest of them, it will again identify which is having the highest probability. So it is going to work in that way. But it will not give a good result in the logistic regression if you apply the multi-class. Generally, for multi-class, will not apply the logistic regression. 90% of the real life projects, whatever we are going to do, nothing we are going to apply on the logistic regression if it is a multi-class. Similarly for KNN also, similarly for SVM also. SVM for binary class only, it will take a highly computational. For multi-class means still more very high. With respect to, it has to increase so much of higher degree, then it can apply that one and it has to separate the data. For generally for multi-class classification algorithms, in real life, if you face any kind of multi-class classification miss, then directly we are going to start from the decision tree onwards. If it is a binary class miss, we'll start from the logistic regression onwards. If it is multi-class miss, directly we'll start from the decision tree onwards instead of applying KNN or SVM. If you apply also, you'll get a very bad result, nothing else. Right? Now, let us see how to calculate this Gini value. Okay, let us see one by one examples. So before seeing this one, let us take a data set, a small data set. I'm having a data set in this way. This data set consists of, okay, this data set consists of two input variables, x1 and x2 and y. The first input variable is performance of the class. Second input variable is class studying. The person, whatever the class he is studying, either 9th class or 10th class. And the output variable is whether he play the cricket or don't play the cricket. In the output variable, I'm having two options, whether he will play or not play. Okay, this is the data set. And for this data set, I have to create a decision tree. For creating a decision tree, I have to take an input node at the starting, I mean root node. Now the root node, whether I'm going to consider the performance of the class or class studying, this variable or this variable, x1 variable or x2 variable. Which variable I have to select? Means I have to calculate the Gini impurity of the x1 variable. At the same time, I have to calculate the Gini impurity of x2 variable separately. And after calculating both of them of Gini impurity of x1 and Gini impurity of x2, which is having the lower Gini impurity, that one I'm going to consider in my root node. That is max we are going to do. But in the Python, in the coding part, fit on x train, y train means automatically it will only do. You don't need to do anything. Now, whatever we are discussing, just I'm explaining only one line of code, that is decision tree dot fit on x train comma y train. If you write this one, what happens in the backend? That one we are discussing. Nothing else I'm discussing. Decision tree dot fit on x train y train, what happens? Before to that, data pre-processing is common. After that, evaluation is common. Everything is common. Hyperparameter tuning is common. After that, rebuilding the model with best hyperparameters is common. Everything is common. If you fit on x train, y train in the backend, how it is going to work? Fit means what? Calculate. What it is going to calculate? That is the interview question. How the decision trees works. From where the step-by-step process will be done. That is important. None of them is going to ask you, okay, how to import the decision tree? What is the Python code for the decision tree? What is the code for the decision tree modeling? None of them is going to ask in the interview that questions. They are going to ask you what is meant by root node, how you are going to select the root node, and what based on what condition, what is meant by Gini impurity, what is meant by Gini index, what is meant by entropy, what is information gain, what is maximum depth of the tree, what is pruning, what is pre-pruning, what is post-pruning. These are the multiple interview questions are there. Decision tree is the maximum subject which has the more number of interview questions. This is the biggest topic in the entire data science, which has the maximum number of interview questions. In real life also, you are going to have 100% interview question from the decision tree, from machine learning perspective. Okay. Now, so here I'm having a data set like this. So please take a photo or you can write in the notes, anything. Instead of writing in the notes, please take a photo, guys. I can understand. Some students are sleeping in the first bench. Some students are discussing with others. Instead of you'll not have that much of interest to write entire things now. Let us take the photo only. After taking the photo, again you discuss with your friend. Okay, no problem for me. If you want miss, you sleep. No problem for me. Right? You should know the priorities. Which one has to be given the priority? Right? Done. Everyone has taken the photo. Now using the photo, open the cameras. I mean, sorry, what are the mobile phones? What are the photo you have taken? Just open the image. Open that image and do the calculation now. Okay. Using that, please do the calculation now. So I'm having total, how many number of students are there in that? Please count. Open your image and please count. Total, how many records are there? Total 20 students are there. In that, how many of them are playing? In that total number of player, 10. 10 records play. And how many of them are not play? 10 records not play, right? So now I'm indicating the persons who are playing the cricket as plus symbol, who are not playing the cricket as minus symbol. Okay. So I'm having an entire data set as with respect to 10 of them are playing, 10 of them are not playing. Total number of students are 20, right? Now, first I'm going to calculate the Gini index of the first column. What is the first column? Performance in the class. Now, I'm going to write one condition, which is nothing but equal to above average, because here I can't use the greater than symbol or less than symbol because it is a discrete variable. For discrete variable, I have to use the equal to symbol. For performance in the class is equal to above average. And answer is true, answer is false. Now separate the data, which is above average students. How many above average students are there? Count the number of students who are, how many of them are above average in the given data set? 14. 14 of them are above average students. And how many of them are non-above average students? Means which not satisfies the condition? No. Is 6 students. 14 students satisfies your condition? Yes. And 6 students not satisfy. And out of 14 students, how many of them will play? Out of 14, how many of them will play? How many of them will not play? Total 14 are there. 14 above average students are there. Within the 14 above average students, tell me how many will play and how many not play. 8 of them will play. 6 of them will not play. Is that clear? Sir, why you are considering play and not play, sir? Because that is the output variable. So I'm going to take with respect to the split versus output variable. Now here, I'm having the play of 8 records, not play of 6 records. And in the students who are with respect to 6 students who are below average students, the below average students within that, how many of them will play and how many of them will not play? Just check in the data set. 2 of them will play and 4 of them are not playing, right? This is the data set. Is that clear? So total 20 students. Out of 20 students, 14 of them are above average students and 6 of them are below average students. And within that 14 above average students, 8 of them will play, 6 of them will not play, 2 of them will play, 4 of them will not play. Now I'm going to calculate the probability of play. What is the probability of play? Playing cricket within the 14 students. What is the probability of playing cricket is 8 students will play. What is the probability? 8 by 14. What is the probability of not playing? 6 by 14. So 8 by 14, which is equal to 0.57. 6 by 14, which is equal to 0.43. Okay. And similarly, total 6 students are there, out of which 2 of them will play and 4 of them will not play. What is the probability of play? 2 of them will play out of 6 and 4 of them will not play out of 6. Now I'm going to calculate the Gini index of this one. How to calculate the Gini impurity of this one? What is the Gini impurity? 1 minus Gini. Now what is meant by 1 minus Gini is 1 minus sigma p square. Now 1 minus, what is the p square I'm having? Two classes are there. One is probability of play, one is probability of not play. What is the first probability? That is 0.57 whole square plus 0.43 whole square. This is the Jenny impurity of this particular node. And this is the, I'm going to calculate the Jenny impurity of this node. That is 1 minus Jenny. That is nothing but 1 minus 0.33 whole square plus 0.67 whole square. Now, once I have calculated the Jenny impurity of this subnode separately and Jenny impurity of this node separately, now what I'm going to do is I'm going to calculate the weighted Jenny impurity. I'm going to calculate weighted Jenny impurity. Why weighted Jenny impurity means this side I'm having 14, this side I'm having 6. If I'm having both sides 10 and 10 means I will simply apply the arithmetic mean. Since both of them are not having the same weightages, I have to go with the weighted average, which I have discussed in the descriptive statistics. When you have to apply the weighted average means when the both of them are having different weightages. Here one side 14 students are there, one side 6 students only are there. So now I'm going to apply the weighted average of this one. That is 14 by 20 into the 0.49 of the first subnode and 6 by 20 of the second subnode Jenny impurity. Now I have got the Jenny impurity of overall node. This is the overall Jenny impurity of this performance in the class. Okay. Is that clear? Performance in the class is Jenny impurity value is 0.475. Now similar way, calculate the Jenny impurity for the class study. You do the calculation, please. Performance, one column I have shown you, right? Now second column, one more column also is there, right? Class studying. Now for class studying, total number of students are, how many total number of students? 20. 20 is the class, total number of students are 20. I'm writing one condition called as class is equal to 9th class. I'm writing the condition class is equal to 9th. True, false. How many students satisfies with respect to 9? How many total number of students will satisfy this one? 10 students are 9th class. Whatever the opposite is, also students are 10. This one 10, this one is 10. Now within these 10 students, how many of them will play the cricket? Who are 9th class and playing the cricket? How many students count? 8 of 8. And what is the not play? Obviously balance is 2. Now what is the probability of playing the cricket? 0.8 is the probability of playing the cricket, that is P1. What is the probability of not playing the cricket? P2, 0.2. Now for this particular subnode, what is the Jenny impurity? 1 minus 0.8 whole square plus 0.2 whole square. This is the Jenny impurity of this node. Play true. Okay. This is 2 and this is 8. Play 2, not play is 8. Okay. 0.2 and 0.8. 0.2 and 0.8. 2 people are playing and 8 people are not playing. But Jenny impurity is same. Okay. Done. For this subnode is completed. Now for this subnode, this one. Now who are not studying 9th class? Total number of students are 10. 10 students are there. In this, how many of them are playing? 8 are playing in this. How many are not playing? 2 are not playing in this. Now, what is the probability of P1? 0.8. What is the probability of P2? 0.2. Now, what is the Jenny impurity of this particular node? 1 minus 0.8 whole square plus 0.2 whole square, which is nothing but same above. Now, once these both subnodes you have calculated separately. Now, what is the overall, this one, impurity? Now, weighted impurity. What is the weighted impurity? That is, how many records are there here? 10 records. That is 10 out of 20. 10 by 20 into the first subnode, whatever the weighted impurity you have got, plus 10 by 20 into the second one, whatever the value you have got here. that you have to substitute, and you are going to calculate this one. Is that clear? So the same thing was written here. Just observe. Okay. So 1 minus 0.8 whole square plus 0.2 whole square, which is equal to 0.32. 1 minus 0.2 whole square plus 0.8 whole square, which is 0.32. This one separate, this one separately. I have calculated the Jenny impurities. Weighted Jenny impurity is equal to weightage. That is 10 by 20 into the first one, 10 by 20 into the second one. Now 0.32. Now I have got two variables are there, two variables Jenny impurity. Now which one I have to select as my root node? Which one has to be selected as the root node? Means class should be selected as the root node and decision tree should be started. In that way, the decision tree will start. Is that clear? If you are having 10 columns or 20 columns, which column will be selected as the root node is the interview question. What is the criteria? Question is, what is the criteria to select the root node is the question. What is the criteria? What is the criteria to select the root node? What is the criteria to select the root node? Answer. Answer for this is, we calculate the Jenny impurity of all the variables. We calculate the Jenny impurity of all the variables, and whichever the variable is having the low Jenny impurity, which variable is having the lowest Jenny impurity, it will be considered as the root node. First, we have to calculate the Jenny impurity of all the variables. How many input variables are there? For each input variable, we have to calculate the Jenny impurity. After calculating the Jenny impurity, whichever is having the lowest one, that you are going to select. Is that clear, guys? Done. One way of calculating is Jenny impurity, and which is having the lowest Jenny impurity, that one you have to select. Second way is information gain. Second one is information gain. Information gain is 1 minus entropy. Information gain is 1 minus entropy. So first you have to calculate again the entropy of the first column, entropy of the second column, and from that information gain of the first column, information gain of the second column. Which is having the higher the information gain, that is the best one. Information gain, clearly the word indicates gain. Gain means positive. It should be higher. Information gain means you are getting more information from that particular variable. The higher the information gain, the good the variable. The lower the information gain, that is the worst variable. You are not getting any information from that variable. For example, a variable is there. One variable is there. This particular variable information gain is equal to 0. What is the meaning of that? Just simple, forget about entropy or all these things. That just it is saying information gain. Just apply a more general English. Information gain is equal to 0 means this particular variable gives the information is equal to 0. It is not giving any information. If it is not giving any information, why you have to use that one? Simply delete. So information gain is also used as a future selection technique. Information gain is used as a future selection technique to identify which features are important or which features are unimportant. Which feature is having the higher information, that will be considered. Which is having the lower information, it will be deleted. Right? Whichever is having the higher information gain, it will be selected. Whichever is having the lower information gain, it will be deleted. Simply. It is one of the parameter which is used for the future selection. How we are having the correlation. Which is having the higher correlation, that will be good one. Which is having the low correlation, we are going to remove now. Similar way here also, information gain. Correlation is applied on the continuous variable. Information gain is applied on the discrete variable. Okay. And whichever is having the lower information gain, that discrete variable, we are going to delete. Yes. Information gain is equal to 0 means we don't get any information from that variable. That is the meaning of that. Now, how to calculate the information gain means 1 minus entropy. Okay. Now, what is entropy? Entropy means the formula for entropy is minus. Entropy formula is minus sigma P into log P to base 2. This is the formula for the entropy. Now, already you know what is meant by sigma. Sigma means what? Summation. So you are going to take minus of overall. If you take like this, P1 log P1 to base 2 plus P2 log P2 to base 2 plus P3 log P3 to base 2. So on up to Pn log Pn to base 2. Now, if you apply minus over that, for everything, it is applying the minus. All right. So basically, entropy means minus of sigma of P log P to base 2 is called as entropy. Okay. And you are identifying the first entropy, and after identifying the entropy, 1 minus entropy you are going to do. 1 minus entropy is called as information gain. Okay. Now, let us see how to calculate the entropy. Okay. Now, here, earlier example, same example, whatever I'm having. Number of students are 14, out of which 8 will play, 6 will not play, and probability is 0.5, 0.57, 0.57, and 0.43. Earlier, what we have done is 1 minus 0.5 whole square we have taken. Why we have taken 0.5 whole square, 0.57 whole square plus 0.43 whole square? Because there we are calculating the Gini index. In that previous example, I'm calculating the Gini. Gini means in terms of sigma P square, that is P1 square plus P2 square. In that case, what I have done 0.57 whole square plus 0.43 whole square. If I am calculating the Gini impurity means 1 minus of, and 1 minus of this one, and that is nothing but 1 minus of whatever the value you have got. 1 minus. That is previous example. In the previous example, we have done like this. Now, what we are going to calculate? Entropy. Now, what is entropy? Minus sigma P log P to base 2. Now, that is minus P1 log P1 to base 2 minus P2 log P2 to base 2. Now, what is P1 value? Same P1 value. Here also earlier, whatever the P1 value is there, instead of doing the square, this time you are taking like this, 0.57 log 0.57 to base 2 minus P2 is 0.43 log 0.43 to base 2. In the earlier example, you have taken the P1 square. This time you are taking the P1 log P1 to base 2. That's it. That is the difference. Remaining everything is same. P is not going to change. Calculation of the P, everything is same. Only difference is earlier you've taken the P square. This time you are taking the log 2 base. Okay. So here 0.57 into log 2 with respect to 0.57 minus 0.3 into log 2, 0.43, and you are going to get some value. Similarly, for the second node also you are calculating. After calculating both of them, you are calculating the weighted entropy. The weighted entropy means this one for the main node. For the main node, you are calculating. This is the for sub node. Each sub node you calculated, and finally from the main node. Weighted one means for the main node. Okay. Now, after that, similarly split in the class also same. That is 0.8, 0.2, 0.2, and 0.8. Earlier example, whatever we have done, same to same. And you are going to calculate. And you are going to calculate from that weighted impurity. Weighted impurity means again this one. Now, once you calculated the entropies, now you are having the entropy of the first column, entropy of the second one. And from this, you are going to calculate the information gain. Information gain is 1 minus of that one. So 1 minus of this. Now, out of these two, which is having the higher information gain? Class is having. So like this, we are going to select the class as the root node. Okay. So either based on the Jenny impurity or based on the information gain, you are going to select the root node. If you are calculating Jenny impurity means Jenny impurity should be low. If you are calculating information gain means information gain should be high. Sir, which one is the best one? Or both are same? Everything is same or difference is there? Or which one is the best one? Just we are going to apply the hyperparameter tuning. In the hyperparameter tuning criteria for the split, we are having two options. We are going to take a dictionary, criteria as the dictionary. Within the dictionary, we are going to give the first one called as entropy and the second one as the Jenny. Okay. If you give like this, it is going to apply the first entropy, it will try and it will do the entire things. After that, it will try the Jenny and that one also will be applied. It is going to apply both of them. Instead of asking the question, sir, this is the best, this is the best, instead of asking, apply both of them. Apply both of them. Whatever you are having in your mind, whether it is correct or wrong, instead of thinking that one, how much time it will take for you to do modeling? After data pre-processing is completed now. Once the data pre-processing is completed, everything is completed, how much time it will take for you to the modeling? For modeling, it will take maximum 5 minutes or 6 minutes of time. Instead of thinking of that question, whether this has to be applied, whether if I apply like this, what happens? If you think that one and if you waste that time for 15 or 20 minutes, instead of that, you can complete the things also in that meantime. So in the entire machine learning or data science, there is no, this is best, there is not the correct one, nothing like that. Everything we are going to apply, wherever we get the best one, we are going to select. Because we don't know, we can't say, there is no fixed rules are available. Okay, for this type of data sets, you apply only entropy. For this data sets, you apply only Jenny index means I used to tell that one. If anything is there like that, any rules or particular rules are there means I will tell directly. Since there is no rules, we have to apply all of them. Is that clear, guys? Now from this, we are going to identify the information gain. And so once again, we are having Jenny impurity, which is equal to 1 minus Jenny index. Next, information gain, which is equal to 1 minus entropy. So if it is a binary class means you are having P1 square plus P2 square. Here you are having 1 minus, again minus of that. Minus of that means directly plus. Plus, directly you can apply the plus symbol and plus P1 into log P1 to base 2 plus P2 log P2 to base 2. If it is a binary class. If it is a multi-class, plus you have to add one more class, one more probability. For each class, whatever the probability is there, separately, you have to calculate the probability. Is that clear, guys? Now, coming to this Jenny index. Jenny index should be high or Jenny index should be low? Jenny index. I'm not asking impurity. Impurity should be low. Impurity should be low means Jenny index should be high. Information gain should be high means entropy should be low. If entropy is low means automatically information gain will be high. If Jenny index is high means automatically impurity will be low. Right? Jenny index is different. Jenny impurity is different. Don't get confused between both of them. Okay, Jenny index means sigma p square. Impurity means 1 minus. Opposite to that. Purity, impurity. One is purity and one is impurity. Jenny index means purity. Purity should be high. Impurity should be low. Information gain. This is called as loss. Loss should be low. Gain should be high. Is that clear? The lower the entropy, the better the result. The best the variable. Entropy should be low. Gain should be very high. Right? Entropy means disorderness. Means, for example, here, if you are having like this, some entropy, let us take an example like this. So in this case, you are having pure, everything of pure one class. Now, in this case, what happens? The entropy is going to be 0 because one of the probability is going to be 0. If one of the probability is 0, automatically the entropy is going to be in terms of 0, right? Now here, in this case, the entropy is going to be the 0, right? Now, log 1 also is equal to 0. See, the P1 into log P1 base 2 minus P2 log P2 base 2. Now P1 is 0. 0 into second one, no need to multiply. Next one is 1. 1 into 1 log 1 to base 2. Log 1 is again 0. 0, 0. 0 minus 0 is nothing but 0. So directly entropy is going to be the 0. Entropy 0 means good or bad? Entropy 0 means what is equal to? Information gain is equal to high. So automatically in this completely pure class is there. Now in this case, what happens? Exactly 50-50 are there. Both of them. That class is 50. This class is 50. Now in this case, what happens means, in this case, the entropy will be very high. No information. In this complete information is there. Everyone will not play. You are getting a clarity. Everyone will play or everyone are not playing. Anything, clarity answer is there. But here, no clarity answer. Okay. Unclarity you are having here completely. So the entropy means simply to say disorderness. Is that clear? Now, so here it is going to work based on the categorical data. Whenever you are having the categorical data, you are going to work like this. For example, if you are having the continuous variable. Sir, how the continuous variable will be, sir? Because classifier means output variable should be discrete only. Na? I'm not saying about the output variable. If the input variable is categorical, we are going to apply either entropy or we are going to apply either information gain or Gini index something. If the input variable is continuous, like in earlier example, age savings and output variable I'm having. What is the age column? Continuous. What is the savings column? Continuous. In that example, how I am going to calculate the Gini then? In that case, how I can calculate the Gini or how I can calculate the input with respect to information gain? So for continuous variables, we have to go with the variance. For continuous variables, we have to calculate the variance. So whichever the variable is having the lower variance, that particular variable is the good one. Right? So we are going to focus on the variance. Okay, based on the variance. So we are going to calculate the variance of the each one. And once we calculated the variance, whichever is having the lower the variance, that is the good one. Right? Now in this way, we are going to create the decision trees. Now, this is the decision tree. Now I have completed the decision tree and I have told you how the decision trees works. Means how you have to select a first node and from that decision nodes and from that how you have to split. Not only the first node, wherever the decision node is there. For example, I'm having like this. I'm having the data like this. X1, X2, X3, X4, X5 and output variable Y. I have first initially selected the I have calculated the information gain of this one, information gain of this one, information gain. I have calculated. Out of X3 is having the highest one. I have selected X3, assume. And I have splitted the entire data into two parts. Okay, splitted. Now, here I have to take one more condition. Now, this time, which variable I have to apply? Now, which variable I have to apply means again, you are going to calculate the information gain of all the variables. Sir, already calculated now. Again, why we have to calculate? Earlier, you calculated for the entire data. Now you are getting the splitted. For example, here 100 data points are there. 100 data points will be splitted into this side. One side you may get 40 data points and one side you may get the 60 data points. For this 40 data points, the information gain will be entirely different, right? Earlier you calculated is for 100 data points information gain. Now for this time you are going to calculate for 40 data points. Now for 40 data points, again you are going to calculate, means in the given data set, for your easiness, I'm saying for a simple example, let us try with a simple. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9. Total 9 records are there, Amma. Total initially 9 records are there. Now out of 9 records, this is having the highest information gain. For 9 records, it is having the highest information gain. And I have splitted the data. After splitting the data, it has to be split into 2 parts. Means in this, some of the records should consider in this, some of the records should go in this. Let us assume this record, this one has went to this one. That is record number 1, 2, 5, 6 into this side. Record number 3, record 4, 7, 8, 9 into this side. After splitting the data into 2 parts, you are having the data was split into 2 parts like this. Now this inside these 4 records, now again you are going to calculate the information gain separately for each column of using the 4 records only. You are not going to calculate for using the 9 records now. Using the 4 records only, you are going to calculate the information gain of each column once again. And which column is having the higher information gain, that column you are going to use, again you are going to split. Is that clear now? And for these 5 records, using the 5 records and this data, again you are identifying which column is having the higher information gain, and that particular column you are going to use, again you are going to split. Like this, the splitting will be continued like this completely till you get the pure nodes as the answer. Is that clear? So in this way, the decision trees works, and finally you'll get the pure answer. Means every record will be correctly classified. Till every record is correctly classified, it will divide. For example, in one of the node, you are having 1 plus and 1 minus. Means one student will play, one student will not play. Again, still it is going to split. Till you get the pure as the answer. In that, minus should not be there. Only pluses, means only one class should be there. Only one class should be there. If at least one student will play and one student don't play, if you're having 2 data points like this also, still it will be splitted the data points into play and not play. Again, it will write one more condition. Still it will write one more condition. Again, it will split. Till you get the pure answer, it will split. It is even 2 records are also, it is split. 10 records also, it will split. Whatever it is. If in the data set, everything I'm having 7 records like this, every one of them are playing, no need to split now. If I'm having both the categories in a single node, then it is going to split. Only one category is there, directly one category is there, no need to split that one. That is no need to split. Right? Is that clear, guys? Now this is called as decision trees. Now there is a problem in the decision tree. What is the problem in the decision tree? Overfit. So the problem in the decision tree is overfit. How? How it is overfitting? So it is focusing on the train data. It is forgetting about the test data. Always the train accuracy is equal to 100% every time. Till you get the pure answer, means 100% only answer. Na? Train accuracy is fixed 100. Blindly 100. Every time. What are the data you give? If you write one blue point here, one blue point here, one blue point here, one blue point, one blue point. And you write one red point here, one red point here, one red point here. I will write one condition. Like this I will write. Still I will get the pure class. Though I will take 100 conditions also, but I will classify the data into perfectly. It is not like SVM, I'm going to write one line only. Na? Whether one horizontal line or one vertical line, I'm not writing with respect to one line. I'm writing multiple lines. The each line is either horizontal or vertical. No slanted lines will be there. Because you are writing based on the condition using the one variable So using this variable, either above or below will be there. So the horizontal line, or you are having the vertical line. So I'm going to write multiple lines. By using the multiple lines, I'm splitting the data. If I'm splitting the data only one line means it is not able, we can't able to split, but I'm splitting using the multiple lines, not with one line. Similar means to be more precise, if I'm using here this one, assume I'm having some red data point here. Some red data point. Now, if I apply the linear line, I can't separate. If by using a linear line, I can't separate this one. If I draw a single line, I'm taking a single line. I'm drawing a single line. Anything you draw, whatever the line you want, you draw a single line, never you can't split this one. But instead of drawing a single line, if I apply the polynomial, that is, I'm taking a shape like this. Now, whatever is inside this one is red data points. Whatever outside is called as blue data points. This is a polynomial regression. But if you want a linear regression, you can't do that. Similarly, for this data set, if you are having a classifier, linear classifier, you can't apply. Okay, means linear classifier with a single one you can't apply, but a linear classifier with multiple lines you can apply. Now, always the train accuracy is going to be 100%, and it is going to lead to the overfitting, the decision trees, because it will focus on the train data. Whatever the train data you have given to that, it will understand that one and it will work irrespective of test data. What is there in the test data, it will forget. It will not focus. Okay. So here, sir, SVM also will focus only on the train data. Even KN also will focus on train data. Everything will focus on the train data, because you are fitting on extend white means obviously it has to focus on train data only. Then what is the difference means? In that case, what happens? In this case, what happens means here this is going to create the number of conditions. How many conditions are there? Every condition is dependent on the train data. For example, here I have to draw this line. Should I draw this line or should I not to draw this line means it is completely dependent on the points. For example, here there is no blue point. This line is sufficient. The above this black line is sufficient. Assume there is a one more blue point here. I'm having one more blue point. Is that sufficient? This one black line is sufficient? No. This one black line is not sufficient. I have to use one more black line like this to separate. When I have to use this one, that will be dependent on this data point. Right? So always the train accuracy, I'm going to get the 100%, and which leads to the overfitting. That is the problem in the decision trees. Now, how we are going to overcome this one means by pruning, means cutting the decision tree. You have to cut the decision tree, cutting the decision tree. By cutting the decision tree. Cutting the decision tree is called as pruning. You have to cut the decision tree. Now, how to cut the decision tree? Cut means you have to remove some part. How we are going to do that one? So we are having two options. One is called as pre-pruning, post-pruning. Pre-pruning means before to the model. Before to the model itself, you are fixing how much it has to grow. Post-pruning means after modeling, after modeling. This is before modeling and this is after modeling. Okay. Now, what is meant by before modeling and after modeling? Now you are having a tree like this. First, what you are going to do is you are going to bring the seeds and you are going to grow the tree. Okay. And the tree is going to grow. Okay. Once the tree is completely grown, okay, after observing the tree, and if it is disturbing you, if the tree is disturbing you, then you are going to cut the tree. If the tree is not disturbing you, why you have to cut the tree? If the trees are fully grown outside in the market, for example, in my house, I'm having one tree. Okay, in front of my house, there is one tree. And the tree has grown such a way that my first floor, you can't see. My entire house, first floor, you can't see. Only you can see the ground floor entrance gate only you can see. The entire first floor is covered with the tree. You can't see the house. If I come outside and if I do some kind of shake, hand raise also, none of them can see. Because completely it is covered with the leaves and branches. None of them can see even if I come outside to the balcony also. Now it is disturbing me. Now since it is disturbing me, so I have cut the tree. To some part of the tree I have cut it. Which part I have cut it? Which was disturbing for me. Means in the balcony area, which I can't even see the outside people, or where there is no sunlight into my house. So that part I have deleted. That part I have cut it. Okay. Now remaining part, what are the remaining part is there? Remaining part I have not disturbed. Remaining part, whatever it is not disturbing me, I have not disturbed. I have not cut that particular tree. So this, when I have cut the tree, after once it has grown, before itself I have not decided. Before itself I have not decided that I have to cut like this before itself. First it has completely grown. After growing, later I decided. This is called as post pruning. Now, for example, for certain trees, you'll have some kind of fencing like this. Have you observed outside some trees? Some plants will have the fencing. Now, the fencing is for security reason. At the same time, the fencing makes sure that the tree will not grow outside that one. It will not come outside that one. It will grow only inside. Means that you are deciding at the starting of the tree only. You are deciding at the starting of the tree only. In the starting stage only, you are deciding that one. Okay, your tree has to grow in this only. It should not grow out of this. You are deciding at the starting only. And if you take a money plant, in the money plant, whatever the you are getting the root, and with respect to this one, you are going to take in terms of which direction you want to grow. You are deciding before itself. You are keeping that one as per your required direction. Before itself, you are deciding. These are all called as pre-pruning. Pre-pruning means before to the model only, you have decided how much it has to grow, how much it has to give the answers. Before itself, you have decided. Then it is called as pre-pruning. And after growing, then you have decided, means it is called as post-pruning. Now here, in this example, first I will make sure my entire tree will be grown completely. Means where I will get the complete leaf nodes like this of pure nodes. Now, if I feel this tree is overfitted, and if this is having certain problem, now I am going to cut this part. Depth of the tree I'm going to give only as 2. I'm going to delete one of the depth. Now I'm going to select only the maximum depth is equal to 2. I'm going to cut this part. Why I'm cutting means in order to reduce the overfitting problem. Now, why you selected depth of the 2 is equal to 2 only? Means first I will see the maximum. What is the maximum depth? The original data itself is having the maximum 3. Now, can I use 4 or 5? How I can use 4 or 5? 4 or 5, I have original tree only. Completely if it grown also, maximum is 3 only. Then how I can write 4 or 5? So first I will observe the entire tree. And after observing, then I will decide what would be my maximum depth. And using that maximum depth, I'm going to cut the tree. If I write the maximum depth is equal to 2, the tree will be cutted up to here. Like this, we are going to cut the tree. Is that clear, guys? So what are the different criteria to cut the tree that we are going to see in the tomorrow's class along with the coding part? And how to overcome this one in the random forest they have created, that we are going to see in the tomorrow's class, guys. Already I have uploaded the notes. Please check your drive. I have already uploaded the notes. Please check the drive, and we'll continue in the tomorrow's class. Right? Done. Yeah.